Hello, and welcome to physics. First topic we will be talking about is one-dimensional motion. We just want to get your feet wet with physics. Sorry about my email popping up there. Go wait. Okay. One-dimensional motion is anything where it's moving in a straight line, so no curving. We'll learn about how to deal with things that move along curves later on in the class. Okay. We need to make sure that we understand some terms, and as an assignment you were already supposed to look into some of these terms. But I didn't have you look at what units. So hopefully you have some understanding of what all these different terms mean already. And if you don't, well, you'll have to go back and look those up. I'm not going to spend a lot of time defining them here because I don't think there's much use in sitting and listening to me define a term and watch me write it down when you could just go to Google and define distance, or go to a physics textbook and look up distance, and plus you should have already done it. But one thing I want to talk about is just what units they come in, and also whether or not they are a scalar or a vector quantity. So in physics it's a little bit different than just like in math. We don't just have numbers. The numbers have meaning. And so with some numbers where we're talking about amounts, they're called scalars. And some numbers are numbers where they have an amount and a direction. So a scalar quantity is one that only has an amount. I really need to get a new pen. And a vector quantity is one that has both an amount, and the amount of the vector is oftentimes called its magnitude. I'm going to run out of space. Magnitude. And then a vector must have a direction. Hey, this pen's really bad. So, which quantities are scalars and which quantities are vectors? Distance is a scalar. Position is a vector. Displacement is a vector. Speed is a scalar. Velocity is a vector. Acceleration is a vector. Time has no direction. Okay? Some of you guys are kind of floating through the life, and you're scalar students. You have no direction. Although those of you in physics, you're mostly vector students. You know where you're headed. Okay? So distance has units. In physics, we like to work in meters. Speed is a distance divided by time, so it's in meters per second. Time is in seconds, is what we like to work in. Okay? Position is also going to be in meters. It's how many meters away and in what direction you are. Displacement is also in meters. So basically displacement is just the vector version of distance. Okay, and they can come up with slightly different answers, and we can talk more about that in class. Velocity is the vector version of speed, and then acceleration is a vector, and it's in units of meters per second, because it's how your how your velocity in meters per second is changing with time. So it's a velocity change per time, which gives it that units of meters per second. So how your speed is changing. Okay, just I guess a real quick thing to talk about. Let's say somebody is running in track, okay, and they go around the track and they finish. The distance they have run is 400 meters. The displacement they have run is 0 meters because they are exactly where they started. Let's say they ran the 400 meters in 100 seconds. Okay, not a great 400 runner. I just chose that because it makes the math easier. Okay, if they ran 400 meters in 100 seconds, their speed would be 4 meters per second. That would be their average speed. If somebody ran the 400 meter in 100 seconds, their average velocity would be 0, come on, meters per second in any direction because they're back where they started. So in that amount of time, their average velocity is they didn't go anywhere on average during that time because at the end of the race, if they would have just stood there, they're in the same place. They wouldn't have won. Can't say, oh, they got there first, but same velocity whether you win or just stand there on average. The instantaneous velocity, which we'll talk about next, is very different. Okay? So when we talk about, again, I'm referring back to the average versus the instantaneous with that track runner. The average velocity at the end of the race is the same for everybody who completes a whole lap of the track. It's 0 because their displacement is 0 at total. But during their instantaneous is very different. The person who wins will have a higher instantaneous velocity for more of the race. Okay? Average velocity is what your speedometer normally measures. Okay? Or, sorry, I'm not thinking. Average velocity is not what your speedometer measures. Your speedometer in your car measures instantaneous velocity. Average velocity, some of you might have a car that has like a trip computer type thing where it tells you on average your car has moved this fast. Okay? It's just taking the total distance your car has moved and the total time your car moved for, and it gets an average off of that. Okay? And again, the only difference between speed versus velocity, if I look at my speedometer, it's telling me my instantaneous speed. If I also have a compass and I'm saying, well, I'm going 100 miles per hour northeast, if I put these two things together, then I have a velocity if you put them both together. Okay, so average is just on average how fast you move, and you get an average here by taking the total distance divided by the time. An instantaneous velocity is a little bit harder to get out of a formula, just, sometimes. But if I know my starting velocity, okay, or velocity at one moment, and I know my acceleration and how long I've been accelerating for, I can calculate an instantaneous velocity at any other time. So one thing about speeds in physics is they are relative. So if I look at these two cars here, if I've got one that's going 30 meters per second, one that's going 40 meters per second, I could say, when I'm doing my physics work, I could say that this one is going 0 meters per second, and this one's going 10 meters per second. Okay, depending on what problem I want to solve, and we'll get more into this like when we deal with momentum and things, because that's where it becomes more important, is that speeds are relative to each other. Okay, so sometimes it doesn't matter that car A is going 40 meters per second. Sometimes all that matters is that car A is going 10 meters per second faster. Like for example, if you were working a problem and I asked you how long does it take car A to pass car B, then it doesn't matter that car B is going 30 and car A is going 40. What really matters and is going to make the problem a lot easier is the fact that car A goes 10 meters per second faster than car B. Acceleration. Acceleration is not a change in speed. A change in speed can be acceleration, but that's not the definition. Acceleration is defined as a change in velocity. So velocity is both speed and direction. Okay, so either one. So if we look at how many accelerators does your car have, well, traditionally we call the gas pedal an accelerator, but the brake pedal can change our speed, the steering wheel can change our direction, okay? And so there's more than one accelerator. You could probably make an argument too, like if I let off on the clutch, that's going to change my speed. If I do something and somehow screw up my transmission, and I just randomly shift gears, if I could get it to happen without popping the clutch, that could change my speed too, all right? So you have more than just one accelerator in terms of how physics talks about acceleration in your car. All right, getting down to actually be able to solve the problems. So we can describe motions mathematically, and that's the nice thing about physics is we can make predictions for where something should be based on knowing a certain set of conditions. You can make pretty reasonable guesses at where we should be at a later time or where we used to be at a time before by modeling the motion by these different formulas. Okay, so this top one is a pretty familiar one too. Hopefully you use it before. It's basically just distance equals rate times time. So distance equals average speed or velocity. So we can read this top one actually two different ways. We can say displacement equals average velocity times time, or we can do distance equals average speed times time. So really a lot of times we like interchange velocity and speed. The only difference when you're doing one-dimensional motion between velocity and speed is velocity can be positive or negative, and speed can only be a positive number. Displacement can be positive or negative. Distance can only be positive. Okay, so that's the difference between them when you're doing one-dimensional motion. So you should have these formulas. You should get them down somewhere where it's always going to be accessible to you when you're doing your physics, whether it's labs, homeworks, tests, whatever. You're going to want to have these. Okay. And I'm going to show you how to use them. So whenever we're doing physics problems, we read through the problem first, we figure out what's going on, we make a pictures, oftentimes helpful, and then we list out all the important stuff. So example problems. An airplane must reach a speed of 71 meters per second before takeoff. Oh, look, it just gave me a speed. I'm going to write V equals 71 meters per second. Because I'm a little bit more clever and I've been doing physics for a while, I'm like, that's the final speed. That's what it's trying to reach. So I'm just going to say that's a VF. Maybe you don't get that yet, and you're like, oh, let's go back, and maybe I'll have to add an F later. It says if the runway is 1 kilometer long, I'm like, oh, it just gave me a distance, which equals 1 kilometer. And then I realized, oh, in physics, I usually work in meters, so that equals 1,000 meters. What must the acceleration be? Acceleration equals question mark. And then I think, is there any other information that's kind of hidden to me? So maybe I should draw a picture. So I've got this, come on, runway. I've got a plane. It's on the ground, so it's got wheels. Okay, it's moving this way. I want to know what's its acceleration. Okay, it's here. It needs to be 71 meters per second. This is 1 kilometer. And I'm like, okay, what about over on this end? What's going on there? Well, there, if the plane's taking off, even though the problem doesn't say that, say, well, the velocity was probably 0 then. Okay? So now I've got 4 things. VF, D, A, VI, and I find an equation that uses those things. I plug my numbers in and I solve. So I go back to my equations and I say, okay, which one has VF, VI, A, D? That one does. Plug in what you know, solve for what you don't, done. Okay, got your problem solved. So in physics, the important thing is setting it up. All right, and so we'll kind of compare answers. That's as much time as I have. I'm not going to go through more example problems. We can do some more in class. Okay, try them on your own first, please, though. All right, so this has been the first video of the year. Done.